In this last section, we reverse the relationship. So far, we've considered how climate change has affected humans in the past. Now we will consider whether humans could have altered climate in the past. This research was done mainly by Bill Rudiman. Rudiman suggests that human activities beginning thousands of years ago have kept the next glacial period at bay. He argues that based on orbital variations, the Earth should have started cooling 5,000 years ago, and it hasn't. Why not? Let's consider the data. Rudiman and others compared methane, carbon dioxide, and hydrogen and oxygen isotopes, which are proxies for temperature, for the present interglacial, shown in red, to an average of previous interglacials, shown in blue. This data all comes from ice cores. Rudiman expected the two data sets to show similar trends, but was surprised. What do you notice in all four data sets? Values for this interglacial are similar to previous interglacials until 5,000 to 7,000 years ago, when the values diverge. Instead of a steady decrease as in previous interglacials, values in this interglacial begin to increase. What does this mean? Scientists have argued that Rudiman's initial comparison was flawed because the combination of precession and obliquity caused variations in solar insolation in each interglacial to be slightly different. Therefore, Rudiman compared precession and obliquity measures for three previous interglacials, named Stage 1, 11, and 19. Stage 1 is actually the present interglacial, the one we're in. Although he found precession was the same for all three interglacials, obliquity was only the same for 1 and 19. Comparing Stage 1 and 19, which had very similar orbital variations, despite Rudiman found that carbon dioxide still diverged, with CO2 increasing in the present interglacial about 5,000 to 7,000 years ago. So what's causing this difference? Rudiman suggests the divergence is the result of agriculture. Agriculture began about 13,000 years ago in the Fertile Crescent, as shown in this map by the green dots. By 7,000 years, agriculture had spread through much of Europe, as shown by the light green and yellow dots. Agriculture, through deforestation, could cause carbon dioxide to increase. In Asia, rice cultivation began in China about 5,000 years ago and expanded to the rest of Asia over the next 4,000 years. Rice production results in the release of methane. Here, Rudiman shows evidence for the increase in methane being related to rice production. The lower panel shows the concentration of methane in the atmosphere based on measurements from ice cores. The upper panel compares these measurements to the expansion of rice production based on archaeological evidence. Time is shown on the x-axis from 6,000 years ago to present. Notice the strong correlation between rice production and the concentration of methane in the atmosphere.